Languages like Java or C++ are often better for learning object-oriented programming because they force you to follow OOP principles. They make concepts like encapsulation, inheritance, and polymorphism very clear and explicit. In contrast, Python is more flexible and easier to use, but that flexibility can sometimes hide these concepts. In this course, we will learn the basic OOP concepts using Python, but it is also important to understand how these same concepts are applied more strictly in languages like Java. In object-oriented design, inheritance describes a relationship between two classes. We have a more general class called the superclass and a more specialized class called the subclass. The subclass builds on the superclass. It inherits both data, which are the attributes, and behavior, which are the methods, from the superclass. This means we don't have to rewrite the same code. We can reuse what already exists and extend it. So the key idea is, a subclass is a more specific version of a superclass, and it automatically gets its data and behavior. This diagram shows a simple example of inheritance. At the top, we have the class vehicle, which is the superclass. It represents a general concept. Below it, we have car, which is the subclass. A car is a specific type of vehicle. The arrow shows the direction of inheritance. Car inherits from vehicle. This means that car automatically gets all the data and behavior defined in vehicle, and it can also add its own features or modify existing ones. Let's look at how the substitution principle appears in Python. Here we have a function called process_vehicle that takes a parameter v and it calls v.move. Notice that we do not specify the type of v. In languages like Java, we would explicitly say that v is a vehicle, but in Python, we don't do that. Instead, Python simply assumes that whatever object we pass in has a move method. So if we pass in a car, a bike, or any object that has a move method, this function will work. This is why the substitution principle still applies in Python, but it is less visible. We are not checking the type, we are relying on the behavior. So we create an object v using the vehicle class and pass it into the function. This is the expected case. The function is designed to work with a vehicle, and we pass in a vehicle. So everything works as expected. But we can also pass in a car, which is a subclass. This works because a car inherits the behavior of a vehicle, including the move method. Now this example helps us understand the substitution principle more clearly. If this function works with a vehicle, then it should also work with any subclass of vehicle, such as car. So this becomes our baseline. If it works with the superclass, it should also work with the subclass. That's the core idea behind the substitution principle. Let's think about the concept of a person. In the real world, a person can take many different forms. People have different backgrounds, roles, and characteristics, but they all share some common features. For example, all people can walk, talk, and interact, but each person is still unique. This is very similar to how we design classes in object-oriented programming. We can define a general class called person and then create more specific types, such as student, teacher, or engineer. Each of these is still a person, but with additional or specialized behavior. So this is a simple person class in Python. We define a class called person, and inside it we have a constructor, __init__. The constructor takes first name and last name as parameters and assigns them to the object using self. Remember, self refers to the current object, so each object will store its own first and last name. Next, we define a method called greet. This method prints a message using the person's name. Notice that we use an F string to insert the values of first name and last name directly into the string. At the bottom, we create an object P1 with the name Jane Doe and then call the greet method. So this example shows the basic structure of a class. We define data in the constructor, define behavior using methods, create an object, and then use it. As shown here, The person class appears at the top as the superclass, representing a general concept. Below it is American, the subclass, which represents a more specific type of person. The arrow indicates the inheritance relationship. American inherits from person. Because of this, the American class automatically receives all attributes and methods defined in person, such as first name, last name, and the greet method. In addition, American can introduce new behaviors or override existing ones to provide more specialized functionality. This is the general syntax for inheritance in Python. We define a subclass by placing the superclass name inside parentheses. So, subclass name inherits from superclass name. This tells Python that the subclass should have access to all the attributes and methods defined in the superclass. This example shows inheritance in practice using person and American. First, we define the person class with a constructor and a greet method. Then we define the American class, which inherits from person by putting person inside the parentheses. Notice that in the American class, we define the same constructor again. This works, but it is actually repeating code that already exists in the person class. More importantly, we override the greet method. In the person class, the greeting is general. In the American class, we provide a more specific message. So when we create an American object and call greet, the subclass version is used instead of the superclass version. This is called method overriding. Here's the most common way to access superclass attributes in Python. We use self. When a subclass inherits from a superclass, it also inherits its attributes. So inside the subclass, those attributes already belong to the object. That's why we can access them directly using self, just like they were defined in the subclass. In this example, even though first_name and last_name come from the person class, we access them using self.first_name and self.last_name. Another way to work with superclass functionality is by using super. Super is mainly used to call methods from the superclass, not to directly access attributes. In this example, we use super.__init__ to call the constructor of the parent class. This allows the superclass to handle the initialization of attributes like first_name and last_name. So instead of accessing or setting those attributes manually, we let the parent class take care of it. It's important to remember that super is designed for method calls. If we want to access attributes directly, we usually use self, not super. Polymorphism means many forms. In this example, we have a base class animal with a method called speak. Then we have two subclasses, dog and cat, and each one overrides the speak method with its own behavior. Now look at the function make_sound. This function takes an object called animal and calls animal.speak. Here's the important part. We use the same function, make_sound, but pass in different objects, a dog and a cat. Even though the function call is the same, the behavior is different. When we pass in a dog, it prints woof. When we pass in a cat, it prints meow. So the same method call, speak, behaves differently depending on the object. That is polymorphism. Before we wrap up, I want to emphasize something important. This lecture covers the most essential concepts related to classes, objects, and methods. However, it is not comprehensive. To fully understand classes and objects, you must read the chapter on classes in the textbook. The lecture is meant to guide you and highlight key ideas, but the textbook provides the full details, examples, and edge cases.
This lecture was prepared by June Lee with the assistance of AI Technologies. See you next time.
Today, we explored several important object-oriented programming concepts in Python, including inheritance, method overriding, the substitution principle, and polymorphism. Python allows us to work with these ideas in a very accessible way, which makes it a great language for learning and experimenting. However, some object-oriented features are not as explicit in Python due to the nature of the language. Because Python is dynamically typed and more flexible, certain relationships and constraints can be less visible compared to other languages. These are foundational OOP concepts, and they are often easier to observe and fully understand in languages such as Java or C++, where the type system is more strict and explicit. For that reason, it is strongly recommended that you also study these concepts in a language like Java or C++. Doing so will help you develop a deeper and more complete understanding of object-oriented programming.
Thank you for your attention today. This presentation was prepared by
준비.
with assistance from AI Technologies. I truly appreciate your engagement. See you in our next class.